Good day to everyone. This is now the third part series of our project entitled Remedial Lessons in the Air. The first part was being given to us by Mrs. Jane Russell Abais, which is simplifying rational expressions. The second one is being given to us by Mr. Chody G. Magana Jr. and it is about special products and factoring. Now, we have the third part of the series, and this is what we call operations of rational expressions. With this lesson, we are having our main objective as we have to simplify rational expressions, follow rules in operations and rational expressions, and number 3, demonstrate mastery in solving operations of rational expressions. Naturally, when you are talking about operations, you are talking about the 4 fundamental operations in math. And all of us know that the 4 fundamental operations includes the first topic, which is the multiplication. Multiplication of rational expressions. When you're talking about rational expressions, you are talking about ratio. When you're talking about ratio, you're talking about fractions. So, based from this, let us have a brief review about fraction first. In multiplication of fractions, we have to deal with the numerator. Say, for example, we have A as a numerator over B as the denominator, and it will be multiplied by another numerator over the denominator. So based from this, it is being multiplied according to numerator by numerator. So when you are multiplying fractions, you are actually multiplying numerator to numerator, which is equal to AC. And denominator to denominator, so it will become BD. So we have having to multiply the value for A over B and C over D, which has a product of AC over BD. Let us have a fraction. So in a fraction, say for example, we have 2/3 times 3/4, or say 3/4. Actually, we are having the value of numerator as 2 and as 3, and a denominator of 3 and 4. So in the first fraction, we have 2/3. The second fraction is 3/4. If you multiply that, we have 6 over 12. But take note, this is not the lowest term. In order for you to have the value, the final value, you express this in lowest term. So in lowest term, we have to express 2 factors, wherein we cancel 6 and 12 by dividing it by 6. Divide this by 6. We have 1 over 2. So the final answer will be 1/2. So that is based from the operations of fractions. And also, based from this, we are dealing about cancellation process. Since we are having the first example as 2/3 and 3/4, we can readily cancel out for the given value. So I will erase this out and apply first the cancellation process. So we have same factor that can be extracted out of the numerator and the denominator. So 3 and 3. So we have to divide this both by 3. So it will be cancelled out. What remains is 1. The 3 here is also 1. And notice that on the numerator and the denominator, there is also a factor that can be extracted out. And that is 2 and 2. So divide this by 2. It will be cancelled out. 2. So you have 2. Then, since it is already prime, you have to multiply numerator by numerator, denominator to denominator. So 2 times 1 is equals to, this is 1. So 1 times 1 is equals to 1 over 1 times 2 is equals to 2. 2. And that is the basic value, the basic process in multiplication of rational expressions. Say for example, class, let us have another topic. How about if we are using the rational expressions? Say for example, we have 3b squared over a times 2a squared over b. So as you can see, there are two variables, b and a. So we have to determine first the value wherein we have to cancel out, because cancellation is the short method of multiplication. We have to cancel out. Now, what is the value that can be cancelled out? So as you can see, we have b here on the upper portion and we have b on the lower portion. So it can be cancelled out. So it will be equal to 1 and this will become b. Cross out the b squared. And also, we have a here and we have a squared. So we have to cancel a squared, what remains is a, and this will become 1. So since they are both prime now, we have to multiply 3 times 2, which is equal to 6. And b times a, which is equal to ab over 1. So the final answer will be 6ab. And this is the final answer. Now, we are having different problems. How about if the problem consists of trinomials, wherein we have to apply what we have knew about the previous topic? Say for example, we have t squared plus 5t plus 6 over t minus 3, and it will be multiplied by another rational expression. Say for example, t squared minus 2t minus 3 over t squared plus 3t plus 2. As you can see now, you cannot cancel on either of the sides of the values. So what you are going to do is, you apply the so-called factors. You have to determine 2 factors of t squared plus 5t plus 6. And based from the given knowledge given to us by Mr. Magana in the previous topic, we have this value wherein it is factorable. We have t squared, so we have t times t. And the process, the value here is 6, so we have to add the value 3 plus 2 is equals to 5. So this is equal to t plus 3 and t plus 2. So these are the 2 factors of t squared plus 5t plus 6. Applying the concept plus meeting over t minus 3. As you can see, this value is equal to this value. And t minus 3 is equal to this value. Times t squared minus 2t minus 3. As you can see, we cannot cancel. So we have to deal first with another factor. So based on this, what are the factors of t squared minus 2t minus 3? So we have first determine the value for t squared. So we have t and t. And then we have the value for the second term, which is a negative. And the sign of the last term is negative. So we are dealing with a plus and a minus. So based on this, we have negative 2. So this is negative 3 times positive 1. Because negative 3 times 1 is equal to negative 3. And if we add negative 3 and 1, that is positive 2. So these are the factors of t squared minus 2t minus 3. Now, we have the numerator. How about the denominator? We have to factor it out too. So we have to factor it out. We have t squared plus 3t plus 2. As you can see, another t will be the first term of the binomial. And we have 2 here. But the middle term is 3. So we have to use plus 2, and plus 1 to complete the equation and to complete the factoring technique. So all of this, what can you notice about the given problem? There is the so-called cancellation process, isn't it? So let us cancel. So t minus 3 can be cancelled out with t minus 3 on the numerator. T minus 1 can be cancelled out. Also, because we are having the value for the numerator and the denominator. What else? We have also t plus 2 and t plus 2. So, since this is now prime, we are having only one value that is left behind. So we have t plus 3 all over 1, because when you cancel out, there is 1 here. There is 1 here. There is 1 here on the portion. So t plus 3 over 1. So this is equal to t plus 3. So we say that t squared plus 5t plus 6 over t minus 3 multiplied by t squared minus 2t minus 3 over t squared plus 3t plus 2 is equal to t plus 3. Is there any question? So based from this, you can readily get some knowledge in multiplication of rational expressions. So let us have some examples.
To multiply expressions, we need to multiply first the numerator of both expressions, which is 2 times 5 is equal to 10. And multiply also the denominators of both expressions, which is g times 3gh is equal to 3g squared h. This result cannot be simplified further because no factors in the numerator and denominator that are common, so that 10 over 3g squared h is the product of this expression.
To find to multiply expression, we need to multiply the numerator and the denominator of both expression. And if there is a common factor, we use the cross cancellation process and cancel the common factor, like b and 4 and 2. The 4 is divided by 2 and become 2. 2 divided by 2, it become 1. And I rewrite the new expression. 2 over 3a cubed and 15ab squared over 1. And I will find the common factor of the expression and cancel it out. Like 3 divided by 3, the answer is 1. 15 divided by 3, the answer is 5. A squared become a cubed become a squared, and a is cancelled. And the answer is 10b squared over a squared.
From this expression, we can get the factor of 2m plus 4 as 2 times m plus 2, and the factor of 3m plus 6, which is 3 times n plus 2. We have m minus 1 over 2 times m plus 2 times 3 times the quantity m
m plus 2 over 4m minus 1. We will use the cross cancellation. We will cancel m plus 2. We have m minus 1 times 3 over 2 times 4m minus 1. So we have the answer 3m plus 3, 3m minus 3 over 8m minus 2.
Okay, how about the last one? Mr. Minero?
In multiplying 2x minus 5x minus 12 over 6x times negative 3x minus 12 over x squared minus 16, you must first get the factors of the both numerators and denominator to simplify it. The factors of 2x minus 5x minus 12 is equal to the quantity of 2x plus 3 times the quantity of x minus 4. 6x is simply a expression, so it is written 6x here. Negative 3x minus 12, the factors of it is negative 3 times x plus 4. The factor of x squared minus 16 is x minus 4 and x plus 4. After this, we must cancel all same terms. We cancel x minus 4 here and x minus 4 here. And x plus 4 here and x plus 4. The remaining is negative 3 times the quantity of 2x plus 3 over 6x. We see that they have common we must cancel this out, but magiging 2 tas this will be negative 1. Negative 1 times 2x plus 3 is equals to negative 2x minus 3 over 2x. It is wrong to have a negative numerator, so we must move the negative side here, and it will become negative 2x plus 3 over 2x.
Okay, thanks a lot, Mr. Menero. So based on the given values we have, that exists that the value for negative 2x minus 3 is equal to the negative 2x plus 3 all over 2x. And that is what we call the multiplication of rational expressions. Now, in multiplication of rational expressions, we're having a rule. So, when you are multiplying rational expressions that have polynomials in the denominator, you just factor the polynomials and then look for the common factors. And you apply cancellation process. Okay, so that is multiplication. How about division of rational expressions? When you are talking about division of rational expressions, you are simply taking up multiplication, because division is the opposite or inverse operation of multiplication. So, by this time, we are having the division process for multiplication. Okay, let us have an example for division of rational expression. Say, for example, we have a cubed b over 2a divided by ab squared over b. As you can see, you have to get the reciprocal of this given value and multiply it on the first value. So you just rewrite the first value here. We have a cubed b over 2a, and the reciprocal here will be b over a b squared. And afterwards, you have to change the operation from division to multiplication. So this is now multiplication process, and then we can apply cancellation process. So we have a and a here, we can cancel it out. What remains is a squared. So it will become squared. And another one, we have a here. So we have to cancel 2a with 2a here. What remains is 1a. We have b and another b. So we have b squared, and we have here a b squared. So it will be cancelled out. What remains is 1, and this is 1 over 1. So based from this, we have a prime factors, and we multiply a times 1 is equal to a over 2 times 1, which is equal to 2. So we say that the quotient of a cubed b over 2a and ab squared over b is equal to a over 2. Okay, so for another example, let us take Miss Asis for example number 1.
To divide expressions, we need to apply the rule for division of rational expressions. First, multiply the first expression, which is 3 over a, to the reciprocal of the second expression, which is 5a over 6. Then, apply the cancellation process. Cancel those factors that are common in the numerator and the denominator, which is a. And as we can see, the factors that are common in 3 and 6 is 3. That's why 3 divided by 3 is 1, and 6 divided by 3 is 2. The expressions that was left is 5 over 2b. 5 over 2b is the quotient of this expression.
Y plus 3 over y plus 2 divided by y plus 2 is equal to y plus 3 over y plus 2 and the reciprocal of the second expression, which is 1 over y plus 2. And let's proceed in multiplication process. Since there is no factor in the same factor in numerator and denominator, we will not use the cancellation process. So let's proceed. Y plus 3 times 1 is equal to y plus 3. And y plus 2 times y plus 2, and we need to use FOIL method. We need to find first y times y equals to y squared plus the outer to y plus times 2 equals to 2y, and the inner 2 times y equals to y, and the last is 2 times 2 is equal to positive 4, and the answer is y squared plus 4y plus 4. Y squared plus 4y plus 4. So the answer is y plus 3 over y squared plus 4y plus 4.
In this expression, a minus 2 over ab divided by a minus 2 over a, we need to have the reciprocal of a minus 2 over a, which is a over a minus 2. We need to cancel out same terms on the numerator and denominator. So we have 1 over b. The answer is 1 over b.
In finding the quotient of this equation, we d over e divided by e squared over d cubed. We just copy the first rational expression and find the reciprocal of the second rational expression. The reciprocal of e squared over d cubed is equal to d cubed over e squared, and proceed to the multiplication process. We simply multiply numerator by numerator and denominator by denominator. D times d cubed is equal to d to the 4th power, and e times e squared is equal to e cubed. The answer to this rational expression is d to the 4th over e cubed.
Okay, we are already through with multiplication and division of rational expressions. Now we will take up addition of rational expressions. Addition of rational expressions are also the same with addition of fractions. So we take up first the addition. Say for example, plus, we have 2 fifths. 2 fifths plus 1 fifth. So the process is addition, but you have seen on the given values, they are both having the same denominator. So in addition of fractions, you have to copy the denominator. So this is 5 and add the numerator. So we have 3. So the final answer will be 3 fifths. How about if we are having 2/3 to be added with 3/4? This is a special case because we are having 2 denominators which is different from each other. So based from this, we have to look for the LCD. The LCD stands for the least common denominator. We have 3 and 4, so we have the LCD which is equal to 12. So based from this, we have to solve using the vertical position. So 2/3 plus 3/4. We'll express this to a similar fraction. So the LCD therefore is equal to 12. In expressing this to a similar fraction, we have to look for the LCD on the 2 fractions. And for this problem, we are having 12 as the LCD. So the LCD will be divided by the denominator, which is 4. So 12 divided by 4, and then it will be multiplied by the numerator. So 12 divided by 4 is 3, times 3 is equal to 9. We are having another value. We have 12 divided by 3, which is equals to 4, is equal to 4, times 2 is equal to 8. So 12 divided by 3 is 4, times 2 is equal to 8. Now, as you can see, we are having similar fractions, and we can add it. So 8 plus 9 is equal to 17 over 12. And this is the final answer. And for enrichment purposes, we are having this kind of problem wherein 2/3, same problem will be used. So we have 2/3 plus 3/4. This is for enrichment purposes only. So plus 2/3 plus 3/4. So what will you do is, you have to multiply the denominator. So 3 times 4 is equal to 12. Then apply the cross product. Add the cross product, I mean. So we have 2 times 4 is equal to 8. Plus 3 times 3 is equal to 9. And then add now. So we have 17/12. In case that we're having the values to be expressed in the lowest term, you can express it in the lowest term. But in this case, it is in the lowest term and it is the same as this value. But this is only for enrichment purposes only. So back to our addition of rational expressions. Say for example, class, I have a value for the first rational expression. In addition process, the rule is when two fractions have different denominators, change the fraction to equivalent fraction with a common denominator and use the least common denominator or LCD and express the ratio as similar fraction. So let us find the LCD. Who wants to take the first exercise on the board? Yes, Miss Aziz?
To get the LCD or the least common denominator, we need to use the prime factorizations. Get the prime factors of the denominators of both expressions, which is 12AB and 3A. The prime factors of 12AB are 2 times 2 times 3 times A times B. And the prime factors of 3A are 3 times A. As you can see, we need to align the factors that are common because they have the same value and they are considered as one factor. Then get the value. 2 times 2 times 3 times A times B is equal to 12AB. 12AB is the LCD of this expression.
Thank you very much, Ms. Aziz. How about the next one? Mr. Marcoma?
To get the LCD of 5 over 12A cubed and negative 3 over 10AB squared, we need to find the least common denominator by using prime factorization. First, we need to find the denominator of both expression. To find the LCD of 5 over 12A cubed and negative 3 over 10AB squared, first we need to find the least common denominator of both expression by using prime factorization. And first we get the denominator of both expression, which are 12A cubed and 10AB squared. The prime factor of 12A cubed are 2 times 2 times 3 times A times A times A. And the prime factor of 10AB squared is 2 times 5 times A times B times B times B. We need to align the common value because the common value are considered as 1. 2 times 2 times 3 times 5 times A times A times A times B times B. And we need to multiply the values, and the answer is 60 A cubed B squared. And the LCD of 5 over 12A cubed and negative 3 over 10AB squared is 60A cubed B squared.
To get the LCD of 1 over 6x and 3 over 4y, we need to use the prime factorization. The prime factors of 6x are 2 times 3 times x. And the prime factors of 14y is 7 times 2 times y. We need to align common value because common value is considered as one factor. So we have the LCD of 42xy.
Okay, thanks a lot, Miss Angeles. How about the last one, Miss Terminero?
To get the LCD of 7 over 6c and c squared over 9d, we must use prime factorization. We must use the both denominators of the expression, 6c and 9d. The prime factors of 6c is equals to 2 times 2 and 2 times 3 times c. And the factors of 9d is equals to 3 times 3 times d. We need to align the values because common values is equal to one factor. 2 times 3 times 3 times c times d. And multiply all the final factors. 2 times 3 times 3 times 3 times c times d is equal to 18 CD. The LCD of 7 over 6c and c squared over 9d is equal to 18 times CD.
Okay, thanks a lot, Miss Terminero. So you know now how to determine the LCD of rational expressions. Now, let us proceed to addition of rational expressions. So let us have the first example. Say for example, we have 5x over 12 plus 5x over 12. So, based from the given values, we have the same numerator. And in addition of rational expressions, if we are having the same denominator, we have to copy the denominator first and then proceed to addition of numerators. So we have 5x plus 5x is equal to 10x. And as you can see now, we have 10 and 12 and we can extract a common factor out of it. We have to divide 10 by 2, so it will become 5. We have to divide 12 by 2 again, so it will become 6. So the final answer will be 5x over 6. So that is for rational expressions having the same denominator. How about if we are having different denominators? Let us have another example. Will you raise it? Okay. Say for example we have x over x plus 2 plus 5 over x minus 6. As you can see, we have two different sets of denominator and we cannot factor it out. So the LCD is x plus 2 and x minus 6. So as you can see, we have to use this LCD in order to perform rational expression, perform addition. So we have first, we have to get the value of the first rational expression, x over x plus 2, and it will be multiplied by the LCD, which is x plus 2 and x minus 6. But since we are multiplying on the numerator, we also use the same value, x plus 2 and x minus 6. Why? It is because these values, two given values on the numerator and the denominator is equal to 1. So if you multiply 1 times x over x plus 2, you will be resulting to the given value in the first expression. So plus, you get now the second expression, 5 over x minus 6. And also, you have to use the same LCD on the first set. So we have x plus 2 and x minus 6 over x plus 2 and x minus 6. So based from these given values, we can apply cancellation process. So we have x plus 2 and x plus 2. It will be cancelled out. What remains is the value for x plus 2 and x minus 6. And for the right side, we can cancel x minus 6 and x minus 6. What do you notice with the denominator that is being left? They are the same, as you can see. So we can apply now the addition process because they are similar in denominator. So we have to continue. We have x times x minus 6 over x plus 2 and x minus 6 plus 5 times x plus 2 over x plus 2 and x minus 6. So we can simplify now. We have x times x, we are having x squared. X times negative 6, we have negative 6x. Plus, we have 5 times x is 5x. And 5 times 2 is equal to 10. This is 10. And the denominator, since we are having the same denominator, we are using x plus 2 and x minus 6. And then simplify further those having similar values. We have x squared negative minus 6x plus 5x, that is equal to minus x plus 10. And copy the denominator, which is equal to x plus 2 and x minus 6. So by this time, you can readily say that the value for x over x plus 2 plus 5 over x minus 6 is equal to x squared minus x plus 10 all over x plus 2 times x minus 6. So we are having this kind of values. Now let us have some more exercises. So in having the value, we have to use number 1. Who wants to solve for number 1? Yes, Miss Aziz?
To add 2 over 3x plus 4 over 3x, to add these expressions, since it is similar or the denominators are the same, we simply add the two numerators, which is 2 plus 2 is 2 plus, sorry.
Tuloy mo lang. Go.
Ulitin ko kaya?
Ulitin mo.
Okay. To add these expressions, 2 over 3x plus 4 over 3x, since it is similar fractions or the denominators are the same, we simply add two numerators, which is 2 plus 4 is equal to 6. Then copy the denominator, which is 3x. Then apply the cancellation process. As we can see, the factors that are common in 3 and 6 is 3. 3 divided by 3 is 1 and 6 divided by 3 is 2. The expression that was left is 2 over x. 2 over x is the sum of this expression.
Okay, thanks a lot, Miss Asis. How about number 2, Mr. Barcoma?
4a minus 3b over a plus b plus 6a plus 4b over a plus b. Since the denominator is common, you just copy it. A plus b and add the numerator. 4a minus 3b plus the quantity of 6a plus 4b. And it's important to have parentheses because it means that this consists of two expressions. Since there is a common value, we need to add it. For a plus 6a equals to 10a. And negative 3b plus 4b is equal to positive b. And the answer is 10a plus b over a plus b.
Okay, thanks a lot, Mr. Barcoma. How about the third one, Miss Angeles?
In the expression, you notice that we have different denominator or we have two different binomials. So we just simply use the two denominator as the LCD. Then, in adding rational expression, we need to multiply both numerator and denominator by the least common denominator. We need to cancel same terms. So we have 2x times x plus 5 over x minus 5 and x plus 5 plus 7 times the quantity x minus 5 over x minus 5 and x plus 5. Now we have the same denominator. We need to multiply the numerator. 2x times the quantity x plus 5 is equal to 2x squared plus 10x plus 7x minus 35 over x minus 5 and x plus 5. You notice that we have same terms, so we just simplify it. So we have 2x squared plus 17x minus 35 over x minus 5 and x plus 5.
In getting the sum of this rational expression, we notice that this expression have different denominators. So we must first get the LCD. In getting the LCD, we must use the denominators and use the prime factorization. The prime factors of 5 5y cubed is equal to 5 times y times y times y. The prime factor of 3y squared is equal to 3 times y times y. We align the common value because common value is considered as one factor. And multiply the final factors. 5 times 3 times y times y times y is equal to 15y cubed. Now we get the LCD. We must multiply it in numerators and denominator of both expression. We notice that they have common factors. 5. 5 divided by 5 is equal to 1. 15 divided by 5 is equal to 3. Here, they have common factors of 3. 3 divided by 3 is 1. And 15 divided by 3 is 5. And they have y2. We cancel out. And y will remain here because the 3 minus 2 is 1. The remaining x plus 3. We notice that the expression have same denominator, so we can add it. 3x tapos we notice that this is not the simplest form of the expression. We get the root. The root of 3x plus 9 plus 30xy is equal to 3 times the quantity of x plus 3 plus 10xy. We notice that they have common factor of 3. 3 divided by 3 is equal to 1, and 15 divided by 3 is equal to 5. And the answer is the sum of x plus 3 over 5y cubed plus 6x over 3y squared is equal to x plus 10 xy plus 3 over 5y cubed.
How about the subtraction of rational expressions? So in subtraction, we are also dealing with addition process, but we have to indicate the minus sign. And you know that we are using the subtraction, and in subtraction we have to change the sign of the subtrahend. Okay, so we have 3 over 2AB minus 5 over 2AB. So based from this, in subtraction, it is like addition, wherein you have to subtract or you have to add if we have the same denominator. So based from these given values, we have the same denominator. So we have to copy the denominator. So 2AB, and we have to simplify 3 minus 5. So 3 minus 5 is equal to 3. So this is subtraction. In subtraction class, you have to change the sign of the subtrahend. You change the sign of the subtrahend and proceed to addition process. So the sign of the subtrahend here is 5. So it will change to negative 5. And we have the subtraction process, it will be changed to addition process. So we have 3 plus a negative 5 over 2AB. So we simplify further. This is equal to negative 2 over 2AB. And since we have the common values, we have to extract factors out of these two given values. 2 can be divided by 2, it will be equal to 1. And 2 can be divided by 2 equal to 1. So the final answer will be negative 1 over AB.
To subtract these expressions, 5 over 4x minus 3 over 4x, since it is similar fractions or the denominators are the same, we only subtract the two numerators. 5 minus 3 is 2, then copy the denominator, it is 4x. Then apply the cancellation process. We can notice that the common factor of 2 and 4 is 2. That's why 2 divided by 2 is 1 and 4 divided by 2 is 2. And the expression that was left is 1 over 2x. 1 over 2x is the difference of this expression.
Okay, thanks a lot.
3 say over say plus 2 minus say minus 4 over say plus 2. Since the expression have the same denominator, we just need to copy the denominator. Say plus 2. Then minus 3 say minus quantity of say minus 4. Since it is negative sign, we need to change the sign of the subtrahend. 3 say, the say in the subtrahend become negative say, and the negative 4 side become positive over say plus 2. 3 say minus say plus 4 over say plus 2 can be extracted. 3 say minus say equals to 2 say plus 4 over say plus 2. And the factor of 2 say plus 4 is 2, the quantity of say plus 2 over say plus 2. And since it have a common factor, we cancel it out. So the answer is 2.
The expression a over a plus 3 minus 3 over a plus 5, we have different denominator. So we just simply use the two denominator as the LCD. The LCD is a plus 3 and a plus 5. In subtracting rational expression, we must multiply both numerator and denominator by the least common denominator. we need to cancel like terms. So we have A times the quantity A plus 5 over A plus 3 and A plus 5 minus 3 times the quantity A plus 3 over A plus 3 and A plus 5. You notice that we have same denominator, so we just copy the denominator and subtract the numerator. But in subtraction process, we need to change the sign of the subtrahend and proceed to the addition. We have similar terms, so we just simplify it. We have a squared plus 2a minus 9 over a plus 3 and a plus 5. The final answer is a squared plus 2a minus 9 over a plus 3 and a plus 5.
In getting the difference of this rational expression, we see that their denominator is different. So we get the LCD. In getting the LCD, we will use the prime factorization. The prime factor of 4p squared is equal to 2 times 2 times p times p. And the prime factor of 6p cubed is equal to 2 times 3 times p times p times p. We get the final factors and multiply it. The LCD is 12p cubed. We will use the LCD and multiply it on both the numerators and denominator of each expression. We can see that there have common factors. 4. So 4 divided by 4 equals to 1 and 12 divided by 4 is equal to 3. We cancel also the p and a p here will be remain kasi ito na ito. Here, the common factor is 6. 6 divided by 6 is equal to 1. 12 divided by 6 is equal to 2. Thus, cancel p cubed and p cubed here. The 2 times 3p cubed minus we notice that their expression have the same denominator, so we will copy it. We multiply this, it will become 6p and this will become 4p plus 6. We will, in subtracting, we will change the sign of the signs. It will become 6p minus 4p minus 6 all over 12p cubed. Subtract the common term. 6p minus 4p is equal to 2p minus 6 all over 12p cubed. This is not the answer yet because it has factor. The factor of 2p minus 6 is equal to 2 times the quantity of p minus 3. They have common factors of 2. 2 divided by 2 is equal to 1. 2 divided by 2 is equal to 6. So the final answer is p minus 3 all over 6p cubed.
Okay, that ends our lessons about operations of rational expressions, and we are leaving you the assignment, which will be passed this coming Monday. This assignment will be written in a one whole sheet of paper, and it will be submitted to the teachers of Mathematics 4. Once again, we are expressing our deep regards to the Pixel Video Productions, and most especially to the owner of the Catbee, the Mambulaw Catbee system, owned by Dr. Bienvenido Torres and Mrs. Marinette Torres. And we are having some fun here. Thank you very much. And stay tuned for the other edition of Remedial Mathematics in the Air. This is Mr. Jovan Gutierrez, Secondary School Teacher 3 of Josefa Aniban National High School, saying thanks a lot and good day.